Hello everyone, welcome to this video on the normal distribution. So normal distribution is a symmetrical bell curve. Hopefully we're pretty familiar with it, we've seen it before. What's new to us today is the function to graph it in our graph mode on our calculator. The only things we're inputting here, the only numbers, everything there remains the same really, except the numbers we're inputting are for the mean and for the standard deviation, which is there and there. And if you put it in the graph mode, it's going to sketch a graph of the normal distribution. Where along here you've got, like here you'll have your mean, and then you'll have your mean plus one standard deviation, your mean take another standard deviation. And on the y-axis, you have the probability. Well, the area under the curve is going to be the probability. So the y-axis is an integral of probability. Okay, that aside, what we're dealing with today, so we will have questions pop up like this, but that's a little bit later on. So I won't talk too much about that now. This is the distribution we've seen. This is the normal distribution. These are the numbers that occur, sort of all naturally occurring phenomena that we can measure is normally distributed. So let's get straight into the question. Now we've seen some notation reasonably similar to this with binomial distributions. We've seen x is binomially distributed with the number of trials and the probability of success. Here we have, if it's normally distributed, we have the mean and then followed by the standard deviation squared, which as we know is the variance. So in this circumstance, our mean is 30 and our standard deviation is 5. Okay, now there will be some worded problems where it tells you what the mean is and what the standard deviation is and the information that you need to use there. So if we're going to draw this distribution right, like the mean is 30, the standard deviation is 5. So it goes up 35, 40, and it goes down as well, 25, 20, etc. Okay, and they're following those, like the probability of it occurring between events is the same as the standard normal distribution table here. So we have sort of 34.13% of the events here, and the same here. We have 13.59 of the events here. That's percent. Okay. So let's look at the first question here. Find the probability that this variable, whatever it is, we're not told the context, it's not so important, we're performing the maths here. This variable occurs between 30 and 35. Okay, well fortunately for us, that matches straight up with our distribution. It's saying what's the probability of it being between 30 and 35? So our answer to A, the probability of 30 being less than X being less than 35 is 0.3413. So for a probability, we need to express it as a number between 0 and 1. Okay, now the other thing I want to point out there is when we're talking about continuous random variables, there is no difference between less than and less than or equal to. Okay, we only need to consider that when we're talking about discrete whole integer values. When we're talking about continuous variables, it doesn't make a difference. Okay, so we don't need to consider that when we're putting that in our calculator. Okay, find the probability of x being less than 22. So what this is saying, so this wants us to calculate this, probability of x being less than 22. And so what we're going to do on our calculator, you might remember this, so hopefully you can see that reasonably well. We'll go menu, statistics, distribution, normal, NCD. And that's bringing up the normal distribution calculations, and we need to make sure we've got the variable setting on. Then we have our lower boundary, our upper boundary, our standard deviation is 5, our mean is 30. Now we're saying it has to be less than 22, which means the highest that it goes is 22. Our upper boundary is 22, 22, and the lower boundary is like minus infinity, okay? So minus, and then E99, maybe you didn't see what I did there. I'll go back up to it again. You press minus E99. That's bringing up minus infinity. Minus E99. There we go. So let's perform that calculation. And so the probability of it being less than 22, this variable, is 0.0505479. Okay, and then to three significant figures, 0548. Now, like here, it might be 1 mark, 2 mark question, but like some advice I give you, just like with binomial distributions, it's good to write down what we're putting in our calculator so that we can determine, so that we can check our answers later on quickly and so that we can, show the marker what it is that we're performing, the calculation we're performing. And so in your calculator, lower, upper, so lower is minus infinity, or you can write minus infinity. The upper is 22, the standard deviation 5, and the mean is 30. So with all that information in there, that's what you've put in your calculator, and this is how you've generated the answer. Okay, let's move on to C. The probability of x being greater than 28. Okay, so this time our lower is 28, our upper is positive infinity, standard deviation remains at 5, and the mean remains at 30. And so if we put that in, so our lower boundary 30, our lower boundary 28, upper boundary positive infinity. So this time you just do E99, and we've got 0.6554. And then to 3 significant figures, that's 0.655. Okay, part D. Find 1, take the probability of B, and then take the probability of C. So if we do that, so in part D, I'm going to do 1, take away, we got 0.0548. And then here we got 0.655. That's going to equal, let's perform that in RunMap. We've got 0.2902. Okay, and state the significance of it. Okay, well, let's think about the distribution, right? I mean, here it's here. I'm going to draw it again so that I can shade on it. We calculated the probability of it being less than 22, so we calculated that event, and we calculated the probability of it being more than 28, so we calculated that event there. Okay, so the mean is sort of here, isn't it? The mean is in the middle there, mean is 30. And so remember, the sum of all probable events is 1. And so if we've got 1 and we've taken away the probability of it being less than 22 and the probability of it being more than 28, then this is the event that remains, okay? So this calculation here, this probability that we've performed, this is the probability of x being between 22 and 28, okay? From our diagram there, that's how we can determine that. And then, calculate that using technology to confirm. So if we go back into statistics, distribution normal NCD, we can go from 22 to 28, standard deviation and mean remain the same, and we've got that 0.2897, okay, and you can see that's going to round up, we get 0.290, okay, so they're the exact same. Excellent, so that's a normal distribution. So it does start off with 8C, like just getting you to think about the distributions, draw them, put the mean on it, and do the calculations based off of problems that involve one or more standard deviation away from the mean. And then it gets into using technology and using some of this terminology as well. So good luck with it.